Once you've been able to do this page, the next page is going to be pretty much exactly the same thing, except instead of writing y equals x squared, we're using function notation. The closest example that we've done so far to something that's like function notation would be this vertex form. When the vertex form happened, you had things that happened inside of the parentheses, things that happened outside the parentheses, something multiplying the outside of the parentheses. All of those same things can happen with function notation, and it's not too bad. So let's do this one. F of x plus 3. That would be the same thing as x squared plus 3. The reason why I can make that substitution, all I did was I replaced f of x is the same thing as x squared, because that's what they told us at the very start. F of x is equal to x squared. So I just replaced it. All that's going to happen to this graph is each little point of the original graph, and not just the ones that match perfectly, it's just that the ones that I put dots for are the ones that I can easily see. But every point is going to move 3 spaces. You don't have to draw the arrow, but I'm just drawing it so that way you know we're doing a plus 3 for every spot. And this is a shift up by 3. And to make this a little more mathy, instead of just saying up, we're going to say shift y by 3. Here's one that's different. If we have f of x minus 2, then this is different than this. But if you remember our old lessons about function notation, anything that gets put right here goes in for x. Whatever is inside of this parentheses for f of x, anything that's in there, you're just going to substitute it where x would have been. Okay? So that means in the equation they gave us, f of x is equal to x squared. But since we now have x minus 2 inside of the parentheses, then this is going to be equal to x minus 2 squared. If you need more practice with understanding function notation, just search up function notation transformations practice. Now that we see that we have f of x minus 2 equals x minus 2 squared, where is that minus 2 happening? That minus 2 is happening inside of the parentheses. It's going to be squared. And if you remember our vertex transformations, that's just vertex form now. Now we have an x in the parentheses and another number. That's just vertex form. And in vertex form, if that's a negative number inside, a negative number means we're going to shift it to the right. So this is a shift x right by 2. So we're just going to take each of these points and go 2 spaces to the right. I'll show you the equation for this one, but you should be able to get it. If this 5 is multiplying f of x, then let's just copy that 5, and then let's change the way f of x looks. F of x is the same thing as x squared, because remember, equals means the same thing as. So we're going to write the 5, and instead of writing times f of x, we're going to write times x squared. And those two things are equivalent. So that means we did this right. All you need to do is graph it and describe the transformation. This f of x plus 5, I want you to try this one right now. Try it. Do this whole problem. And now I'm going to show you the answer. If you didn't already do it, pause the video. There you go. We got the same graph as the parent function, only this time it's 5 spaces to the left. Finish this page and the next page, and that'll be it for today.